I'm Allison Patronella. I'm a seagrass research scientist at the FWC, and today I'm going to talk to you about some of our new seedling research. So we're collecting these turtlegrass seedlings that are washing up on shore, and these seedlings are not going to plant themselves out in the open. Once they end up in the rack, they're pretty much going to dry out and die. So right now we're collecting the seedlings that are caught up in the rack, and we're taking them to a greenhouse nursery where we plan on growing them out to a larger size, and then we can replant them. So the seagrass that you might know as turtlegrass, or Thalassia testudinum, can reproduce sexually or asexually. Asexually means it makes a clone of itself, or sexually means that it has flowers and fruits, and out of those fruits come seedlings. When the fruits open up, the seedlings will become positively buoyant. They'll float for a little bit, and most of those seedlings will settle down to the bottom and become a brand new seagrass plant. But some of these seedlings will wash ashore and they won't ever get a chance to become a seagrass plant. So we're trying some new research where we collect these seedlings from shore that are still viable, and we're growing them out in a greenhouse on the FWC property. This project is really trying to find new ways to plant turtlegrass without harming any existing turtlegrass beds. When we do collect the seedlings from shoreline, we're experiencing around a 50% survival rate. Now this is really quite good because we're picking them up from the high tide line. They've been out of the water for hours sometimes. They're in the heat, in the sun, and the fact that about half of them do survive once we put them back into water is really encouraging because we're not removing anything from the system. We're not collecting seagrass from a pre-existing bed. We're not taking the seedlings out of the water that might find a nice place to settle. We're collecting seedlings and we're trying to reintroduce them into the system as healthy living plants. What we do is we've got both trays and pots with sand, and we'll just go ahead and gently place the seedlings in the sand. Once they make contact with that sand, the seedling will start to grow tiny little root hairs, and that will keep it facing upright before they grow their nice meteor roots. We keep them for about 6 to 8 months, and once they're large enough, we are using them for a seagrass restoration project over at Wolf Branch. Now, Wolf Branch is a large sandy area over near Apollo Beach, and it has had a lot of seagrass loss over the past couple decades. Instead of using regular restoration techniques, where you would collect seagrass from one location and plant it in the other, which harms the original bed, we are collecting these seedlings, growing them up into maturity, and planting them out at Wolf Branch. This is a pilot study, and so far we've done a couple of small planting units just to test the viability of this research. We're testing a couple of different things with our first outplanting. We have rows of quadrats. Each of our quadrats is its own specific test. It can be of density, it can be of location collected. We're looking at a lot of different parameters in this study. And each seedling is its own plant. When you put it in the ground, it can start to grow out clones from its rhizome and expanding to become a larger seagrass bed. Now, when you see a seagrass bed in the wild, sometimes that entire enormous bed can be 1 or 2 plants because of all the clonal growth. It'll grow clonally, and the new clone will grow more clones. And it's amazing how large seagrass beds can be specifically a handful of individuals. But in this case, we have so many unique individuals that we are planting out into Wolf Branch. We're hoping that this will also increase survivability of our outplants because we have such a broad genetic bank. Our beds we're going to continue monitoring for 2 to 3 more years depending, and we're always coming up with new things that we can study. What about the genetics of these? How do we make them the easiest to plant? The seagrass beds that we've planted from our first year study are doing really well. They're kind of hard to tell apart from the nearby beds, which is fabulous. We've seen multiple seahorses, scallops, there are shrimp and fish and crabs, and it's just really heartening to see this beautiful tiny ecosystem that we helped to replenish.